Obviously, we don't want to be making replicated content, and the NCI user guides are a really great comprehensive resource. What we're aiming to do with our USyd material is just have a one-stop shop, I guess. So you can jump on that page, click on the tab you want, and then from there jump out to the relevant NCI page. But you should certainly, if you're inclined, go through the NCI user guides and check out what they have available there in addition to what we're offering. So I might start sharing my screen. So for today's session, we're going to be looking, spending about half an hour on job scripts on Gadi and comparing those to job scripts on Artemis. And for the second half hour, we'll be looking at data transfer. So we've picked these as the first two because through the drop-in sessions that Nat's been running, we've been having a lot of questions around data transfer, naturally. It's a big thing because we need to make sure we have all of our data transfers in place off Artemis to RDS. And also if you want to start working on Gadi now, you can do that. So that's a really important one. And then adjusting, of course, our Artemis workflows. We've got some other hot topic questions coming up that we'll have drop-in sessions for as well, and those include running parallel jobs on Artemis and how to fit within that Walltime that we have on Gadi. So we'll be working through these over the next couple of fortnights. If there's anything else that you would like a half-hour focused training session on, please let us know and we can try and build some content around that too. So from your USyd Gadi onboarding guide, we're looking at running a job, job scripts and submission. So fortunately, NCI's Gadi uses PBS Pro, same as Artemis. So that's taking a lot of difficulties away from porting our scripts across. So the things that you're familiar with doing on Artemis, creating a PBS or portable batch script and submitting it to the scheduler with the qsub command are all going to be very, very familiar with you on Gadi. You'll have some PBS directives in your script, and for the most part, these are very similar to what you have on Artemis. There's a couple of NCI specific things, and we'll look at that later on. The scheduling of the jobs is slightly different. You don't need to worry about this. You simply submit your job, same as what you did on Artemis, but the way that the jobs are prioritized in the queue is slightly different. So on Artemis, you would have heard of the fair share policy, where you can submit as many jobs as you can get onto the system, and the more you submit increases your project's fair share weight, which does go down over time. It has a half-life. And that was to try and make equitable access to the system. So infrequent users could easily get their job on the queue and they weren't always queuing behind heavy users. The scheduling priority is different on Gadi. So all jobs have equal priority, and the only factors that limit how quickly your job leaves the queue and starts running are the resources that you request combined with the current resource availability. In addition to that, you need to have sufficient service units in your project. So we will later on in the content have a look at the queue charge rates and how to work out, do you have enough service units to run? And our USyd scheme, our Sydney scheme, I think is really generous and really helpful for Artemis users. I think you're going to really enjoy working on Gadi. The queues have a much higher throughput, and the way that we are enabling you to access the service units under the Sydney scheme is very, very simple. There's no burden. So in the past, we would require an HPC allocation, which was based on merit. So you'd need to fill in, create basically an application form with benchmarks and justifications, and it was competitive. There was NC Mass, which is still going, and also our HPC Sydney allocation scheme. So now we don't need to worry about that. If you're an NC Mass user, please continue to do that, but you have this Sydney scheme in addition. So in summary, for job scheduling, appropriate resource requests, current resource availability, and your service units, which you don't need to worry about too much because we can easily provide you with more as you need. So now onto the main bread and butter for this section, which is the PBS directives. So this link here, NCI Gadi PBS Directives Guide, has a bit more content, but in summary, this is like a basic, simple PBS set of directives that you might have. There are, of course, other things that you can have, but this is your basic. Familiar to you will be -P, that's your project. So this is going to be your NCI project code, not your University of Sydney RDS project code. The queue name, in this case, the normal queue, and we'll have a look at the queues in a bit. And then some resource requests. So all the resource requests are with -L. So NCPUs, memory.
Oh, Tally,
Yep.
wait, you're only to share, wait, what do you, we can see your screen, but we can only see your Chrome browser, I think.
Oh, sorry, am I sharing the wrong screen?
Yes, I don't know what is that.
Let me try again. It switched my screen 1 and screen 2, and that often throws me. Apologies for that. Okay, so you want this one. Can you see PBS directives now?
Yep, good
Awesome.
stuff.
Whoops. Okay, so here is what we're looking at. And if you wanted to jump across onto Gadi, if you've already got an NCI account and you want to start a script, you can copy this and use it as your baseline if you wanted to. So jobfs is the local to the node storage on the Gadi compute queues. Walltime, same kind of way that you'd request this on Artemis. This here L storage is a specific PBS directive that's required for your Gadi scripts. So you can see here I've loaded the project, or I'm accounting against the project AA00. This path here, scratch AA00, is loaded by default. So whatever project you include here, this is by default. So if you're only using your local scratch directory for input and output that you have accounting against, then you don't need to include that. I typically leave it in on all my scripts because I'm often chopping and changing using KSU from one project and storage from scratch or GData from another. So if you've always got L storage in there and don't rely on the default loading of scratch/project, you'll avoid some no such folder directory errors that can be a bit confusing. GData you'll always need to add in if you have it. Now note the syntax here. There's a plus in between every storage location, and the leading slash on the path is omitted. So we don't put /scratch, which you would need to do if you were going to say navigate there. And likewise with GData, we don't do /G/data, we leave off those leading slashes. Why NCI structured the requirements for the syntax like this, I don't know, but just something to be aware of. You may sometimes see it in the NCI documentation without a space here, -L storage, all one word. That's equivalent, so the space is irrelevant here. The other difference here to a typical Artemis script is I have this directive -LWD. This is not required. It's equivalent to CD PBS-O workdir, which I know is commonly used on Artemis. It's just a handy way of avoiding having this extra line in your code. So hopefully nothing too foreign there. So under this subheading, differences between Artemis and Gadi PBS scripts are mostly what I've just talked about, looking at that demo script. But an important distinction is that you do need to request a specific queue. So on Artemis, generally you would be requesting the default queue, and that would read in your resource requests and have a look at the queue availability and then route you onto a suitable queue based on those factors. On Gadi, we need to request a specific queue. And so the way to do that is to have a look at the actual Gadi queues against what resources you think your job needs and decide which you think it's going to need, and then provide that to -Q. So the normal queue is like your general purpose workhorse queue. It has 4 GB of RAM available per CPU and maximum wall time of 48 hours. This queue is the most ubiquitous as far as the number of nodes. So if you were going to be running a multi-node job where you required 200 nodes, normal is typically the one that you're going to be using. So we'll have a look at the queue limits page quickly. Again, jumping out to the NCI user guide. So you can see here it's broken down in subheadings. So the cascade lake is your main general purpose. Sorry, are we able to mute? Thank you. So click on the drop down. So Cascade Lake is the newer kind of general purpose nodes on Gadi. And you can see there's the normal queue. This is what our demo queue was using with 48 CPUs per node, 190 gigabytes per node, and so on. There's some express queues, also huge memory queues, mega memory queue. Your copy queue is a Cascade Lake queue with a maximum of 10-hour wall time, and there's some GPUs on this set of nodes as well. So all the information that you need is going to be found on the queue limits page and also the queue structure. So if we can have a close look at the normal queue, this will tell us some more information about the actual hardware. So if these things were critical to your job, you could have a look at the normal and decide which was most relevant. If you're wanting to use GPUs, you can have a look at queue structure and have a look at the details on the 2 GPU queues there. So when you're going to be running your first job on Gadi, you can take your data, your scripts from Artemis, adjust your directives, and then have a look at the queue structure and queue limits page to work out what you're going to be putting at -Q. If you submit a job that is requesting something that's not permissible on that node, for example, too much memory, too much time, you will obviously be rejected when you enter your queue sub command. So then you have the opportunity to go back and fix that up. So another detail which we will cover in a later dedicated mini training session is that job arrays are not permitted on Gadi. So if you do typically use this PBS J directive, then we will show you how you can use a utility called NCI Parallel, which is basically a custom wrapper for OpenMPI. And it can be a little daunting at the start because it's a bit more overhead on your part as opposed to just using a job array. But once you grow familiar with it, it's very powerful and very simple to use. A final distinction when you're comparing an Artemis job to Gadi is that the Gadi compute nodes lack internet access. So if you have a job script that typically performs an external network call or a web download, you will need to adapt that before you can submit it to a Gadi compute queue. So Gadi does obviously have a copy queue, which has internet access, but it's not suitable for compute because it only allows single CPU tasks and also has a maximum wall time of 10 hours. So we can have a look at the at a website which is linked from this documentation somewhere. Walltime. Oh, here we go. I've got the link here. Working within wall-time limits, a couple of options for you to split your single job into a series of smaller jobs, use Near and Cloud, which has a theoretically unlimited wall time, or if neither of those are suitable for you, you can request special exception to have the Gadi wall time limit lifted for your single job on a case-by-case basis. So these are the main kind of differences between your Artemis and Gadi workflow, the L storage directive, requesting a specific queue, working within the wall time, making sure you have enough service units, which we'll look at further down in this section, lack of job arrays and lack of internet access. So that might seem like a lot, but as I said earlier, I'm sure you're going to really embrace and love working on Gadi. It's a very, very vast HPC compared to Artemis with much newer and more specialized hardware. I've been using Gadi exclusively for a couple of years now, and I much prefer it. So our dummy script here, very little difference. We're going to do module loads. You're familiar with the module commands from Artemis, and then whatever commands that you require for your job. So no real difference there. So now going on to selecting the right queue, we did have a look at that already. I'll just mention something I glossed over before was the Cascade Lake queues versus the Broadwell queues. So Cascade Lake are newer. So these were purchased for Gadi. The Broadwell queues are from the previous decommissioned HPC called Raygen. So they're older. Because they're older, they're a little bit slower, but they do have some advantages. First of all, different NUMA domains and different numbers of CPUs. So you have 48 CPUs per node on Cascade Lake and 28 CPUs per node on the Broadwell queues, and also higher memory per CPU. So some of the nodes have 128 gigabytes of RAM, some of them have 256. So 256 across 28 CPUs is around 9 gigabytes per CPU. So if you have a task that needs just a little bit more memory per CPU than is available on the Cascade Lake normal nodes, but it's not enough to justify huge mem, the Broadwell queues can be particularly good for that purpose. Another advantage of them is that they have a lower charge rate. So on the queue limits page, there is a column here called charge rate. So you can see on the normal queue, your charge rate is 2, and on the normal Broadwell, it is 1.25. So if you're trying to get a lot of compute through with as minimal service unit cost as possible, the Broadwell nodes can offer some advantages there as well. So another thing to note is the dash exec, which you would have seen here. So you can see normal BW and normal BW dash exec. Don't submit to exec, that's the execution queue. You will submit to just the regular queue name, in this case normal BW, and that will then be routed onto the execution queue. So similarly, if you run the qstat-q command, which just gives you a summary of jobs on the system at present, you can see there's the normal queue and the normal exec. So exec means either in queue or running, currently executing, where the normal queue are jobs which have just been submitted and not yet been picked up and put onto the execution queue. So just remember to always put just the normal queue name and not the dash exec part. So now we'll have a look at queue charge rate. So Nat had a look at this a bit yesterday in the drop-in, if anyone was there. As I mentioned, you can find the charge rates in the queue limits table, a different charge rate per queue, and these vary between 1.25 that you'll see on the Broadwell queues, right up to 6 service units for some of the more specialized scarce resources. Now this, the service unit charges are very important to the way that jobs are queued on Gadi. As we talked about earlier, there's no fair share. It's all based on service units and accounting. So the onus is on the user to, first of all, ensure that when they submit their job, they have enough service units for that job to run, but also to be using the resources in an appropriate way. So the reason, for example, that the Express queue is charged at 6 service units instead of 2 is to ensure that people aren't just running everything on Express, because that's not fair. We want an Express queue for when we really need it and not for just general purpose everyday use. Likewise with the GPU queues, they're charged at a higher rate to ensure that they're only utilized by the jobs that genuinely need them. So don't be alarmed by these charge rates. If you need a queue that has a charge rate of 6, go ahead and submit to it. First of all, the Sydney scheme can provide you with more service units. So don't be afraid that the job's going to cost a lot and you shouldn't run it. If that's what you need, please use it. The Gadi accounting method with these charge rates, combined with the much stricter wall times, the newer hardware and software, and the fact that Gadi is much larger than Artemis, will likely see your jobs get through the queue and complete much faster than what you're typically used to on Artemis, where sometimes we've seen 3 or 4 weeks queue time, which can be very frustrating for your research. So we have a new set of challenges to deal with here, which is working within the Walltime and understanding which queue to use. But in the long run, this is going to be really beneficial for your research. So understanding the charge rates is important, first of all, to make sure that we are wisely using the KSU, which have been kindly provided to us for free, and also making sure that our job can actually run. So to have a look at that in practice, let's say you have a brand new project on NCI and you've been given your default allocation of 1,000 service units or 1 KSU, and you want to submit your job with these resources. You want to run a whole node on the huge mem Cascade Lake queue for 12 hours. This job won't actually be placed onto the execution queue. When you run qstat, it will show a status of H or held. Now this is because this job does not have enough service units to run. So the way, I'll have a look at how you can calculate that, but first of all, show you this command here. which is NCI_account -P, and then your NCI project code. So that will show you how much you were granted for the current quarter, which is 1,000 service units by default, how much has already been spent in the quarter. The reserved amount is how much is attributed to jobs that are currently running or currently in queue for that project, assuming that they run for their full requested wall time. And then finally, how much is available. So we can see that we have less than 1 KSU, just shy of. So why can't this job run? There is an equation, and you'll also find this on the NCI Gadi job costs page, which tells you how to calculate the service units for your job. Now that's hours times max times charge rate. The charge rates we've already looked at. Wall time hours is clear cut. Max is based off typically your number of CPUs that you request, but sometimes memory. So for each of the nodes, there's a total amount of memory on the node and a total amount of CPUs. To get the average amount of memory per CPU, it's based off simple division. So in this case, 1,470 divided by 48 is around 31 gigabytes per node. So if you request per CPU, sorry, if you request more than 31 gigabytes of CPU, you'll be charged based off the memory component. Let's say you request 1 CPU and 64 gig of memory, that's consuming the memory of 2 CPU. So it will be charged at 2 CPU instead of 1. So it sounds a little bit complex, but do jump across to the NCI Gadi job costs page, if I can quickly find the link for that, and they will take you through some more examples of how to calculate that. The Gadi user guide is, the pages are loading pretty slowly at the moment. I'm not sure why. Just drop this in the chat. So with this calculation, our 48 CPU times 12 hours times the charge rate on the huge mem queue, which is 3, sums to 1,728 service units. So we're about 800 shy. So for this particular job, we have 2 options. We can obtain more KSU. And as Nat described in the drop-ins, that's really simple to do. Jump across and go to this additional service request tab, click on this link and fill in the form. Option 2 probably should be option 1. Have a review of your resources and think, do I really need to request that much? So you might have thought, okay, well, I'm not really sure how long it takes. I'll just request 12 hours and that should be fine. But really, in reality, you've got an idea that your job might run in 1 or 2 hours. So you could reduce the resources that you've requested. For example, changing this 12 to a 2 would then drop our job cost way down to 288 service units, and then this job could run. So there are 2 ways to reduce the resources. Obviously, you can kill the job with the qdel command, edit the resources in your script and then resubmit, or you can use the qalter command. So for example, for this job to reduce the wall time, we would do qalter-l, wall time equals 2 hours, followed by the job ID. So then the next scheduler cycle would pick that up, change the resources to the job, and the job could then go onto the execution queue. So here I've got a couple of queue selection examples. It might be nice if I'll just stop talking for a couple of minutes and have a read through, click on the queue limits and queue structure page and see if you can work out what you would put for these 4 examples. Might start having a look at the responses now. Hopefully you've all had a go at this and starting to become more clear. So for a single CPU job with 2 GB of RAM, that's less than the 4 GB of RAM per CPU on the normal queue. So that would be suitable. A whole day, 24 hours, is of course less than what we have on the normal queue. So this job could easily fit onto normal. It does obviously have other options. So the Broadwell queues, which I mentioned before, either the normal version of the Broadwell queue or the Express. As for which is more suitable to you, obviously if it's urgent, use Express. If it's not urgent, use one of the normal queues. And to determine which one you wanted to run out of Broadwell or Cascade Lake, you can do a bit of benchmarking, and we're going to be covering that in one of the later sessions. So for example 2, this job has a higher memory requirement per CPU than what is provided on the normal queues. So you'd be looking at one of the huge mem queues, either the normal Cascade Lake or the huge mem Cascade Lake or the huge mem Broadwell. You could have a look at the equations to work out the charge rate and see obviously that the Broadwell is much cheaper than the Cascade Lake huge memory, but again, the newer hardware executes faster, so it might be more beneficial and ultimately more cost effective for you to use the Cascade Lake huge mem, because the 2 hours of Walltime might actually only take 1 hour instead of 2. For example 3, this one's a little bit trickier. It requires you to dig deeper into the columns of the queue structure page. So if we need a minimum of 20,000 CPUs, we would be needing one of the ubiquitous node types, which is on the normal. You can see here that in the default wall time limit, that for 20,000 CPU request, the maximum wall time is actually 5 hours. As for the why 20,016, not 20,000, that's because once you go beyond 48 CPUs for your job, it must be in a multiple of 48. And you'll see that in other columns as well. When you're requesting multiple nodes on Gadi, excuse me, you can't request parts of nodes. They have to be whole nodes. And then the GPU, there are 2 options, and which one you choose will depend on what you need for your software. And then finally, I touched on this earlier, lack of internet access on compute nodes. If you have the requirement to reach the internet, you can split your job to do a download, save to persistent disk, and then your compute job that reads in those files that you've saved. You could also look at running ARE, which Nat has demoed in the drop-in sessions, which provides a graphical user interface based on Gadi's compute queues with internet access. And of course, you can use cloud as well. Submitting a PBS script is the same as what you do in Artemis, simply with the qsub command. So I haven't covered this here because this is not an intro HPC training course. It's focused. So if you do need a little bit of guidance with this, please jump across to the NCI page, or alternatively our intro to HPC SAH training sessions. If you're familiar with interactive jobs on Artemis, it's the same on Gadi. You use the -I flag on the command line, NCI project code and resources, and then you will obtain an interactive queue. Our final difference between running jobs on Gadi versus Artemis is persistent sessions. This is a really cool service which NCI have provided mainly around running workflow management tools like Nextflow, which require to run for a long time, sometimes much longer than that 48 wall time limit. So the persistent session is something that you launch, run your workflow management tool, which will then launch a series of compute jobs. And where those compute jobs go and in what order they go is very dependent on your workflow, the configuration that you set up, but ultimately the head job will run on basically like a login node persistent session on Gadi that you can log in and out of. It will stay alive even after you close your laptop or your computer. And just flick off jobs to the compute queues as needed. So don't use this queue for computational work, large downloads, or anything intensive. It's just a long running session that you can use for workflow management. So that's all I was going to cover for the PBS scripts today. Hopefully that's answered a lot of questions that you might have about porting your Artemis workflows to Gadi. If there's any questions about this, please sing out now.
While you're thinking of questions, I'll start sharing my screen.
Yeah, think of questions as you go, drop them in the chat. Tom's now, what are you talking about, Tom?
I'm talking about data transfer.
Data transfer. This is useful.
Hopefully. Okay, can you see that?
See your screen, yes.
All right, so we're moving now to a different tab in the user guide. If you go to working on Gadi and transferring data, I will follow along through the material in there. As Callie said, I mean, the idea here is really to give Artemis users a sort of introduction to how to transfer things over to Gadi. And so much of the stuff in this page is actually mostly about Artemis specific stuff, and in particular, the research data store and how to copy things from there over to Gadi. And vice versa. If you want sort of a general data transfer introduction, the NCI pages are, of course, the place to go. They're very comprehensive and worth reading. I started this page with just a sort of an overall introduction. We're sort of learning as we're going as well. I'm particularly learning as I'm going. Unlike Callie, I've only been using NCI for a couple of months now. And so what I've done is just summarize all of the different options that I've currently looked into that are listed on this page. I mean, of course, there are many, many more options, but these are the ones that we're currently sort of looking at. This is the pros and cons. This is sort of a working table. As we learn more things and as new things become available, we'll update it and put new information there. So I'll get started. The place to start is just where we're going to put things on Gadi. And it's not that dissimilar to Artemis. You have a /home space, which only has 10 gigabytes of storage space. That cannot be increased. It works very similarly to your home space on Artemis. You should only store small things there, like program code, batch scripts, configuration information, and the like. Space is very limited there. So yeah, you shouldn't be storing project data there, even if it's a small amount of project data. Where you should be storing project data is in /Scratch. /Scratch is the sort of real workhorse space of Gadi. It's owned by your project. So when you apply for a project, you will automatically be able to access your /Scratch/project ID space. It has 1 terabyte of available space, and that can be increased if you make a request to NCI. It is basically equivalent to /Scratch on Artemis, but with some very major differences. Data is not backed up like on Artemis, but the files that are in /Scratch and are not accessed for more than 100 days will be quarantined for 14 days and then removed, and that's automatic. So you can have the files removed from quarantine. You'll be warned when the files go into quarantine, but you have to then actively go and have them removed. So what you really should be doing is backing up your data as much as possible. And what we'll discuss here is how you copy that data over to the research data store. The preferred place for USIG researchers to back up their data is RDS, the research data store, rather than Gadi's mass data, because it's free to all of us. Mass data will actually cost you SU and things like that. The third space is your G data space, and that's you can access that through /G/data and then your project ID. It's also owned by your project, and it has whatever space was allocated to you by the scheme manager when you first set up your project. That, of course, can be increased, as has been discussed a few times now. Those files are also not backed up, but they will persist there for the lifetime of your project. And it's intended to be used to store longer term files that are regularly read by your project during its lifetime. It shouldn't be the workhorse when your scripts are run, where things are being written to and read from. It's just for longer term data. But remember, that space will also, at the end of your project, that will also be removed. So again, always remember to back things up to RDS as often as possible. So just to say, I think this sort of came up in one of the earlier sessions that Nate ran. Even though Artemis is being decommissioned later this year, RDS is not being decommissioned. And any RDS projects you currently have, they will still be there. And just to say, before Artemis disappears, it's your responsibility to back those up, and preferably to RDS. You can look at the SIH training series pages to see how to go about that. There's a lot of information online about it. So we will basically be talking about how to transfer between Gadi and RDS. You can also, this should be applicable to other methods like your own laptop or your own server and Gadi. But again, if you want to do it that way, look at the NCI documentation for that, because there's a lot of information there about the sort of general cases of how to do this. Yeah, so just to say, you can break these data transfer options down into three kind of groups. For small transfers, like very small transfers, less than a gigabyte, even preferably much less than that even, you can just use a GUI-based data transfer client, which I'll demo quickly here. Such as, I mean, I know a lot of people use FileZilla or CyberDuck on Artemis, and you can do the same thing on NCI. There's just minor differences between the host names that you have to use. You can also transfer things at the terminal, so you can log into Gadi and sftp things directly to RDS. I'll also demo that quickly for you all. And you can use that for sort of slightly larger transfers, but again, not too large, because you end up flooding the login nodes with your processes if you keep doing large transfers on the login nodes, and that's not something that NCI recommends. For the largest transfers, and in fact, generally, as often as you possibly can, what you should be doing is using the data transfer queue on Gadi, and that's called copy queue. It's very similar to the Artemis DTQ data transfer queue that some of you might be familiar with, and I'll take you through, if we have time, running a script there, and that has a few different options which we'll hopefully look into. Just to mention, when you transfer data to and from Gadi, you should always be using what's called the data mover node. That's gadidm.nci.org.au. That is specifically set up for data transfer and won't flood the login nodes with your processes that are doing data transfer. Those nodes are intended to be used for these kinds of operations. Yeah, so just to go through some of the different options, I'm just going to upfront talk about Globus. I don't myself know a lot about what it is, but what I understand is that it will be the solution for most of the problems that exist now with data transfer. It should be simplified. It's easy to use in a GUI. It's easy to use at the command line. It can resync data that hasn't already that hasn't already been finished copying. The problem at the moment is that even though we are setting it up, we're still waiting for it to be finished set up. I think it's with cybersecurity or something like that at the moment. So it should be available in the coming months. And of course, what we'll do once Globus is available, or what I will do, is learn it and then put it on this page, and hopefully maybe do another training session along those lines to let people use it, because that should, if it works as intended, supersede a lot of the things that are already mentioned here. Okay, so just as a first example, I'll show you how to use a GUI to transfer data between RDS and Gadi. I'm on a Mac, so I'm just going to show you how to do this on a Mac, but on a Windows machine, you can browse to something called Map Network Drive rather than your Finder on a Mac, and you should be able to do it there. There are instructions on how to do this on the website there. Essentially, what you're going to do is mount your RDS directory into onto your local machine. So if I load up Finder, I see there we go. If I go to Finder and then go to Go and then click on Connect to Server, you'll see I've already done this because I don't want to have to type it all in, but essentially you're connecting to this address here, this SMB, and just remember to get the slashes the right way around, and then you put in your unikey, in my case that one, and then at shared.sydney.edu.au/research data / and I'm going to connect. You can connect to whichever project you want on RDS. Remember, on RDS, where your files are stored is in a directory called prj- your short project name, and in this case I'm just going to use a training project, but you can use whatever one you like. And if I then click connect, it will, on a different screen, ask me for my password. So oops. Oh, come on. There we go. Takes a bit of time, and then you can see I'm actually in the training directory on RDS, and I've actually set up a few directories here just for some demos that are coming along. But this is basically just a folder in my Finder, so I can do anything I want here and copy files from my local laptop to it, and this is a connection to RDS on my local laptop. So next of all, I'm going to use CyberDuck, load up CyberDuck, and then I'm going to connect to Gadi using CyberDuck. So if I open a connection here, I want to pick SFTP, SSH file transport protocol. That's the only one that will connect you. And then if I use the server, so as I said, always use gardidm.nci.org.au. So
Do you know why that is? Like, you can use the Gadi ones, but I think just for smaller files.
It's just because they don't want people flooding the nodes with too much compute. The login nodes should only be used for generating scripts and submitting.
Yeah, of course.
That's the idea. And then my username. So this will be my NCI username. And then my password's already there. And so this will connect me to my home directory on Gadi, in which I have nothing. I can then browse here to my Scratch space. It's pretty quick to do it this way. You can type it directly in as well. At the moment, we have this training project on Gadi called QCO3. So I'll just go to there. And there you can see this is my project space on QCO3. I've made my own little directory here called TM0464. And in here, there's a whole bunch of files. And so I can very easily, if I want to, transfer by just dragging across, transfer files between Gadi and RDS. And that's the simple way to do it at the command line. But again, there are a lot of caveats associated with this. Don't use it for terabytes of data, because imagine you walk away from your computer and it goes to sleep, or imagine the network shuts down. You can't restart and you're stuck. You have to try it again. So the recommended way is to try and do those kinds of things using the data queue or the terminal. Yeah, and also just to say it's a lot slower to copy things that way than it is on data queue as well, because your laptop itself is an intermediary, and so all of the network transfer is going through your local network onto the external machine, and that slows things down massively. So for small transfers of just individual files, small text files, what I just showed you there is absolutely fine. But if you've got a lot of terabytes of whatever kind of data, you shouldn't be copying it this way. So yeah, so I'll take you through the second, very quickly take you through the second option here, which is to actually do something similar to what we just did, just copying some data, but doing it at the terminal, so at the login terminal to Gadi. So if I bring a terminal up and I SSH to Gadi, so this time I have to log into the login node. You can't SSH into the data mover node. You can only SSH into the login node. So yeah, SSH Gadi. Sorry, not DM, nci.org.au. And then that's incorrect. I need my login. So you've got to sort of get used to the idea that you've got your YuniKey and your NCI login, which are usually different. Okay, and so now I'm in Gadi, and I'll just show you a simple transfer. If I lose that Finder window, it's quite neat to be able to see these things. Let me just get back into it. Next. Okay, so that's just showing my directory tree on RDS, and I'm just going to show. It gives me an idea of what to copy from there. So the only way, one of the things I haven't really talked about in detail yet is that when you're on Gadi and you're copying from RDS or Artemis, RDS and Artemis are very stringent security. And so the standard things that people often use, or you may have heard of, sort of commands like SCP or rsync, Those don't work when you're copying from RDS. The only protocol that works is something called sftp, the only command that works. And so all of these examples will be using sftp. And that's one of the slight differences between using Artemis and using Gadi, is that if you're copying from Artemis to Gadi, you can just use rsync or scp, but here you have to use this command called sftp instead. So I'll just follow the instructions here. So I've SSH'd in, and then that's prompted me for my password, which I've entered. And then to copy some data from RDS to here, let me actually just go to my Scratch space. And start in here, yeah. So let's try copying the directory my data, which contains a file main.zip, from RDS to Gadi. So we would do sftp -r, which just means copy directory, but it can be used for copying files as well. And then you start with your unikey. And then to connect to RDS, we connect to research data ext. So just to say, from Gadi, you should always use research data ext. That's external to the Sydney network. Even if your local computer, the laptop you're logging in from, is on the VPN or at uni, you won't be able to use research data int on Gadi, because it is always a separate place to the university. So Sydney.edu.au. And then we put a colon and we point it to the location of the file on RDS we want to copy, /RDS/PRJ-training / and so yeah, so that RDS directory is the PRJ with your short project ID there. And then I was going to copy the directory called my data. And I can copy that to, let's put the full path. So that's now you just put where you're going to put it on Gadi. You do /scratch. /QC03, that's the project name, and then TM0464. And then it will think for a while. Often it will ask you for your password. In this case, I have SSH key set up. I'll talk about that in a few minutes. But you can see it's then that's the simple way at the terminal to just copy data across. Again, I'm in the login node here, so I'm doing something that NCI are not recommending. But again, this is fine for very short transfers of small amounts of data. If you're logged in and you want to copy a log file quickly or something like that, you can certainly do it this way. Yeah, I'll just stick with that. You can also copy the other way. So the command to do that is sftp your unikey. Well, basically you log your sftp into RDS and then you're putting a location. So it's a slightly different command, but it's essentially the same idea. I'm going to skip over Artemis using rsync because that's covered in the SIH documentation pretty heavily, and also Artemis will be shutting down, so it's probably better you learn how to do these things on Gadi now rather than stick to using them on Artemis, because once Artemis shuts down, you'll have to move over anyway. So the next, just to say as well, when you're in a terminal, you are able to put things. So, if this were a big copy while I was in the terminal and you went away, and again, your computer went to sleep or something, or the network connection broke, or you logged out, you accidentally logged your computer out and you forgot that you were doing the transfer, there is a way around that happening. And what you can do is use something called tmux, that essentially allows you to run a terminal in the background. So here on Gadi, if I type tmux, it will open me up inside a tmux terminal, and I can type whatever I want, whatever commands I want here, or do my copy. And then while that's running, I can type Control-B and D, and that will detach the terminal. It's still running in the background, so your copy is still going on. And you can log out of Gadi and log back in and do whatever you want. Go away, go home, come back to work, and then you can you can reattach the terminal to see how things were going. To do that, you just do tmux attach. And you can see the terminal is back there with all the commands I had, but if it were running something, that would still be running in the background. That's just an control. That's just an aside for if you need that kind of functionality. The last thing I want to talk about, because I think I am running out of time, is using copy-queue. This is the main data transfer queue on Gadi. It's essentially like DTQ on Artemis. And any kind of scripts that you had to do this previously will probably be easily converted as long as you follow what Ali just went through. And so, a lot of that stuff should be easy to convert. Just to say, you can't run jobs on the compute nodes that will copy a lot of data from somewhere. You have to use the data queue, the copy queue to copy your data. The compute nodes don't have internet access. So as I understand, is that ARE does have internet access on the compute nodes.
Yes, that's
so there may be a way around it using that. But if you're just doing standard queue submission on at a terminal, you have to copy your data across first. And this just reiterates that when you're copying data from Gadi, from RDS onto Gadi, when you're logged into Gadi, you can't use the standard well-known commands like rsync or SCP. You have to use sftp or another command called lftp, which I'll briefly talk about. If you're going to do it this way, if you're going to copy things using copy queue, you have to set up SSH keys so that you can do the data transfer without having to type in your password, because otherwise when you submit the job to the queue and it starts running, it will just be asking you for your password in the background and you won't be able to type in your password. So you have to set up these SSH keys. I've already done that. There are very, very, very comprehensive instructions on how to do it here. I'm not going to take you through them. Essentially, the idea is that you create these public and private RSA keys through a sequence of commands, and you copy one of the keys, I think it's the public one, is copied over to your login on RDS. And then what that means that it just reads those private keys, and when you log into RDS, you won't have to type in your password. But this is absolutely essential to do first. And it's useful anyway, because it's nice not to have to type in your password anymore. All the time. So it's useful to set this up if you want. So what we've provided is a bunch of template scripts for transferring data. These are PBS scripts that you can use to submit to copy queue and transfer your data with SFTP. There's a script that transfers from Gadi to RDS and another script that transfers from RDS to Gadi. And so basically the idea with these scripts, you can find them, you can either copy and paste them from this web page, or they are actually on the on Gadi in/scratch/qco3 in data transfer scripts, and you'll be able to just copy these scripts there. And what they are, they have a bunch of PBS commands and the copy command, and you just fill out the blanks which are described in the header of the script. And so you can go through, copy your thing and fill in the blanks. What I'll do is I'll really quickly, I think I'm running out of time, go through an example of trying to do this. So if I'm in my /scratch/TMO464 space, I can copy the template script from /scratch/QC03/data transfer scripts /Gadi scripts. And you'll see there's a few in there. Let's do from RDS to Gadi. But if you want to go the other way around, you just use one of the other scripts. I'll copy that here. And then that script is sitting there in my directory. I can edit that using nano script name. And then this is the same as what you see on the page here. And I will edit that very quickly with the PBS directives we need for the transfer. So our NCI project, the QCO3, we can call our project transfer. That just means all the log files will have transfer. We're going to mount Scratch QCO3 on when we're doing the copy. And then our remote user on RDS is our unikey. And the host, again, is always Research Data X. You can change this if you want to use something other than RDS. You can change the remote host here and username to whatever you want it to. And then the path on RDS. So let's do our training. And my data. And then where do you want to put it on Gadi? That's the next thing. So we're putting it in /scratch / our NCI project / DM0464. And then let's just put it in a directory with a slightly different name, my data 2, which will get created when it does the copy. You can put it, if you put another directory there, it will copy the whole path inside that path. And another thing to mention, in the remote path, if you put a trailing /, it won't copy the parent directory. It will copy all the files inside that directory, which is a neat little trick if you don't want to copy the parent directory. And so that's our PBS script modified. That's simple. And then we can just run it with qsub. RDS to Gadi. And that's submitted to the queue. And now that sits in the background, so I can check that, qstat. Window, and you can see it's in the queue at the moment. Eventually, it doesn't take long, things that are in the data transfer queue. So you can see it's on the copy queue, and eventually it will run, but we might not have enough time to see the output. But just quickly, the last thing I wanted to talk about is that this method of data transfer will only allow you to copy all the data at the same time. So if you've got a large data set, it will copy it all every time you run that transfer. There is a way as well of syncing the data, so you can only copy the things that have recently changed. And that's using this command called LFTP. And we have provided a template script for that method as well. So imagine you copy everything from RDS and you run a script and it modifies a few files on Gadi, but you want to back up just those few files, but you don't want to go through the whole directory tree and work out which ones they are. You can just run this sync script and it will only copy the files that are necessary. So that saves you a lot of time copying, and it won't copy the entire space that you have. And so you can, much the same way I just did, you can modify you just copy the script over and modify the variables in there. And yeah, this is what I just said. There's just an example of how you might use this SFTP and LFTP method to copy your data over. And yeah, again, I'm not going to talk about Artemis DTQ because that's already covered in other places, and you should be doing this stuff on Gadi. Let's have a look. So it looks like my job is finished. So you can see it's put there. My data 2 has copied, so the thing to do is to always check and see if your data has arrived. And you can check the log of the transfer by just looking at these outputs, very similar to on Artemis. So you can see it's fetched my data on RDS to my data 2, and gives you some information about the run. I'll stop there because I think I'm very much out of time, and ask you if you have any questions. I follow the chat. It's a lot of messages.
Good stuff. Thanks, Tom.
Sure
All right.
thing.
Yeah, if there's no questions, feel free to reach out on any of those email addresses and everything, and we'll keep filling out these documentations and getting useful things. NCI has started their training program, so check out their stuff as well.
Yeah,
Thanks
just to
very much.
mention, did you say it in the chat, Nate? You can join the QCO3 project that I've been using if you want to play around with some of these things and try them out. Yeah, I think you have said it there.
Good stuff.
Yep.
Thanks, Callie. Thanks, Tom.
Hi, everyone.
Bye.
Bye.